Good morning. Welcome to our webinar today. This webinar is presented by Energize St. Paul. Special thanks to the city and Molly Smith for coordinating logistics and promoting the webinar. For those who aren't familiar, I want to share a brief introduction to Energize St. Paul. As a partnership between the city and public, commercial, and residential buildings, Energize St. Paul aims to make the city the first place that existing buildings can go to make their buildings more efficient, reducing utility costs and greenhouse gas emissions. The Race to Reduce is an offering from Energize St. Paul's, the Energize St. Paul program focused on maximizing efficiency in large commercial, multifamily, and public buildings with operations and maintenance-based solutions. Participating buildings are currently benchmarking their energy use, participating in networking events and webinars like this one, and utilizing tips from our partners to implement energy efficiency strategies. In addition to joining Race to Reduce, St. Paul is aggressively pursuing efficiency in its own buildings via a $1 million revolving loan fund for energy efficiency projects that to date has resulted in reduction of about $1.5 million in energy costs to the city and received about $1.2 million in utility rebates. St. Paul is considering expanding this fund significantly in the 2019 budget year. I forgot to introduce myself. I'm Carl Samuelson at Xcel Energy, and I'll serve as our moderator today. Throughout this webinar, please submit questions using the question interface on the webinar. Our presenters are looking forward to responding to questions at the end of the webinar. This webinar will be recorded, and we'll share a link to the webinar with participants afterwards. Hopefully, if it's of value, you can share it with other people in your organization. I'd like to briefly introduce our two speakers and then turn it over to them. Eric O'Neill is a professional engineer and an engineering manager at Xcel Energy. Eric has worked in a variety of areas, including energy modeling, retrocommissioning, commissioning, control specification, and energy auditing. And he'll be sharing our overview of using your building automation system to control your energy use. Taylor Thelemann is a product portfolio manager at Xcel Energy. He manages programs that serve commercial and industrial customers, including retrocommissioning, turnkey services, and building operators certification programs. And Taylor will be giving us an introduction to Xcel's retrocommissioning program in the second half of our webinar. With no further ado, I'll turn it over to Eric.
All right. Good morning, everyone. Like Carl said, my name is Eric O'Neill. I'm going to be going through looking at your control systems and trying to get some of the low-hanging fruit as far as energy efficiency goes.
Here are some results, starting with one.
Sorry, we're having some. There you go. There we go. All right. So I'll start this off just by discussing a little bit about who this presentation is aimed for. We're primarily looking for, or aiming this presentation at people who have influence over current building operations, but those that don't necessarily have the deep expertise in control systems that might allow really complex control strategies to be implemented in-house. So we're looking for people who are motivated to keep costs low and who are looking for easy and quick ways to save some energy and save on the utility costs. And I also want to be focusing here on the basics. There's a lot that you can do with not very much effort, and it's a perfect example of the 80-20 rule, where you can get 80% of the wave, 80% of the results by only doing maybe 20% of the work. So those 20% of the effort can be very substantial in terms of the results that you can achieve from them. And I'd also like to focus a little bit on the order in which I would recommend prioritizing energy projects. So I'd first work on conservation, and when I say conservation, I mean just turning things off that don't need to be running and using less of things that you don't necessarily, or that you are currently using. Next would be using things more efficiently, so things that do need to run, try to find ways of making them operate more efficiently. And then once you get to that point, then I would start discussing greening your supply, so looking at wind or solar energy power. Those are going to be the order in which you get the most bang for your buck in terms of reducing your energy costs, and if you're taking the effort on overall reducing your carbon impact or any other form of utility bill reduction. So, okay, so the first real strategy, which should not come as a surprise to many people, is just turning things off at nighttime or turning things off when they don't need to be run. This typically is as simple as programming in some time of day controls into your control system, whether that's a programmable thermostat that you've got on your house thermostat, or a DDC system where you have more individual control over the schedules of pieces of equipment within your building. And typically when we are looking at scheduling opportunities, we're talking months, if not weeks, rather than years in payback. So the paybacks can be incredibly fast and really very lucrative. So as an example of this, I kind of wanted to give what might be considered a worst case example. So as we look at one of our projects that we've recently worked on, this was a hospital in western Minnesota where they had to run a lot of their equipment all the time for obvious reasons in a hospital. But not all of that equipment needed to run all the time. They have clinic spaces and administrative office spaces and things like that. So we recommended that they just simply schedule some of that sort of thing off at nighttime. Unfortunately, because their systems were fairly outdated, they actually had to do some repairs and add some basic controls to the control system there to be able to do that. And that ended up costing about $52,000. However, the payback or the savings on that was about $38,000, which yielded a payback of 1.3 years. So this is about the worst case scenario that you can imagine, where you have to install a whole bunch of equipment just to be able to turn things off. A typical building operator will be able to go into their control system and add some scheduling and control things off with much lower, if not no cost. So many of these scheduling opportunities we see are incredibly lucrative. As another example, we often walk into buildings where we'll see lighting systems that are on and operating, and if they are turned off, even while people are in the space, oftentimes people don't even notice that they've been turned off. So in this photo you can see some uplighting that was turned on during the daytime when there's ample daylighting coming through the clear stories, and those lights were effectively doing nothing in terms of illuminating the space. So just by turning those off during the daytime periods, you can make great strides in reducing your energy consumption. Okay, the next thing is using more automatic modes. So one of the big struggles that I think a lot of buildings may have that's a little more hidden is that there's a number of overrides that have built up over time. So a lot of controls operators will have the ability to go in and manually override certain pieces of equipment and operate them at in a constant way, which ultimately ends up causing some troubles and typically ends up pushing the energy consumption higher than it needs to be. So my first recommendation here would be to do either some kind of notification system where if an override's been in place for a certain amount of time, get a notification so that you can go back and and remove that override and get the system operating back into a more automatic mode, or just have the overrides only be temporary in order to prevent them from doing any lasting harm. Sometimes overrides are the quickest and easiest way to fix a problem, so we don't necessarily want to get rid of the capabilities of doing an override. We just don't want the changes to make lasting impacts on the utility consumptions. The other thing is implementing programming of any task that's currently being done manually, particularly if those tasks are done fairly arbitrarily depending on you know, weather patterns outside or just operator instincts. Typically speaking, those programming changes can be done more automatically using some intelligent sequencing, and that can also take some of the burden off of the operators from having to manually change those things throughout the season. So it can bring efficiencies, and it also can free up people's time and brain power to be contributing to to be fixing and working on things that are more prudent for their time. Another thing we typically suggest is trying to have operators understand above a component level in their systems. So looking at the system level can give a better picture of how all the different pieces come together into the system. But one thing I hear very frequently is that operators don't really understand how that system works as a cohesive whole. Oftentimes, like in this diagram on the screen, there may be separate plants. In this case, there's two different cooling plants on different sides of the building, and those cooling plants operate independently of each other. So without a cohesive understanding of how all of those things operate together as a useful system, then things that are done on one side of the system can cause ripple effects throughout the entire throughout the rest of the system, which can end up forcing things to go in the wrong direction. So whether this is doing some training of operators that's specific to the buildings that you're working with, or whether it's just working with the operators to make sure that they understand how the system as a whole is operating, can be very fruitful in terms of making sure that when changes are made to that system, that they're being done in the most energy efficient way possible. Next, there's some general preventative maintenance that we often see is neglected in buildings, and these things can end up adding up over time and contributing to energy degradation. So things like dirty filters and loose belts and leaky valves are all things that may end up degrading over time and should be checked regularly. Certain companies and facilities operators will have preventative maintenance plans put in place to be checking these things. But other things may slip through the cracks. So in the diagram, or in the image on the left, you can see a thermal imaging camera shot of, this is a perimeter window system where it was about 103 degrees outside when we took this picture, and at the time the overhead radiant panels were operating full blast, so they were contributing a substantial heat load to the space, which absolutely did not need that. So that was a matter of getting some pneumatic tubing reconnected and put back into place to get to get that control back under control. So there's other things like fixing flex ductwork damage and boiler chiller tube cleaning, fixing economizers and outdoor air damper controls, and looking at sensors, particularly humidity sensors. We see our big trouble sensors. CO2 sensors also tend to have a high failure rate. So those sensors, if they're used in important calculations or as part of an important sequence within the control system, incorrect sensor readings there can lead to some degradation in the energy performance of the building. So as an example of this, we were in a facility that had year-round steam and chilled water usage, and we went into one of the pieces of equipment, and we found that there was steam running continuously through the steam coil, and yet the air that was coming out on the other end was very cool. And what we found was that the cooling coil was therefore just picking up all this additional heat that the steam coil was releasing into the air, and it was dropping it back down to levels that were suitable for the space that that unit was conditioning. So that likely had been operating that way for years, and because nobody had specifically looked at whether their valves had any problems, they were basically running their cooling system to offset the amount of heat that was being put in by their steam system. And when we did the math, it came out that was about a $57,000 annual cost for them. So that's a little on the extreme side. Many places won't have equipment that's quite that large, or wouldn't make that sort of thing more obvious, but there's certainly places where that can have such a huge impact. So little things like a single steam valve can have massive impacts on a piece of equipment. Then the final thing we'll go through here is just some basic control upgrades. So these are things that you might take to a controls contractor, and because they're fairly ubiquitous now, and most controls contractors are going to have a good sense for what you're asking for and how to implement it with some reasonable degree of success. Obviously, as an engineer, I would say that having somebody with some engineering background help you out with this would be worthwhile. But these are some things that certainly can be done without any formal documentation or anything like that. So the level of results will vary there, but these are fairly straightforward things that you can talk to controls contractors about. So doing temperature or pressure resets on an air handler, most contractors have done that fairly regularly, and it's typically standard fare on new equipment. Looking at pump throttling and removing that pump throttling to adding a VFD to do effectively do the throttling is a pretty easy thing for most contractors. That may be a mechanical contractor or a balancing contractor that is doing that, as well as the electrical contractor for adding a variable frequency drive. Adding occupancy sensors to spaces that have intermittent occupancy. For instance, in certain buildings, like an office building, they may have a fitness space, and that fitness space may potentially have occupants in it at any given point of time. So they may run 24/7, whereas in reality, that fitness space may only be used between 5 a.m. and 7 a.m. and maybe 5 p.m. and 8 p.m. So by adding an occupancy sensor, you can drastically reduce the number of hours that piece of equipment is running. Adding some temperature and some zone temperature dead bands can allow spaces from fighting with each other, and can remove, if you can remove some of the user controllability. One thing that we see very often is a thermostat being set in the morning by somebody walking in and turning it all the way into cooling mode, and then later in the afternoon somebody turns it into a heating mode, and it's a perpetual fight. So that can have some substantial energy impacts. So taking that sort of thing out of the user's control and standardizing it in the building can help prevent that sort of fighting from happening. And depending on your system, you may have the opportunity to shut things down, like a boiler or other pieces of equipment that don't need to run depending on seasonality. So as an example of this, we looked at a hospital that was built in 2013, and it had what's called variable air volume system, or a VAV system. And that system was set to run at a constant temperature all year round. And the reasoning for that was they had a couple electrical rooms that had a fairly high heat load in them, so they needed cooling year round. Well, we recognized that would end up penalizing them during most of the winter months. So we recommended that they pulled those electrical rooms off that VAV system and reset their discharge air temperature. And that reset saved $55,000 a year at a cost of a little over $5,000. So that paid back in just over a month. And on the chart on the left, you can see the before and after comparison of their energy usage, and that's a fairly dramatic fall off in terms of how much energy the building was using. So some of these can be fairly dramatic and have pronounced impacts on your utility bills. The final kind of tip or recommendation is to keep your eye on ASHRAE Guideline 36. This is a guideline that's still in the works, but the intent of it is to have standardized best-in-class sequences of operation that can be taken from one building to the next, and it will optimize energy efficiency. It has research-based evidence that some of the sequences will actually improve comfort conditions. The idea behind the committee putting this guideline together is that manufacturers can standardize on these sequence of operation, and any owner can say, I would like ASHRAE Guideline 36 sequences, and the owner can then, or the controls contractor knows exactly what they're asking for. They probably have a pre-built set of programming that can be easily taken and duplicated into the new building, which can end up having some cost reduction benefits as well. So this is something that is hopefully going to do some good things for the building controls industry as far as standardization, energy efficiency, and occupant comfort. So keep an eye out for it, and when it comes out, talk to your controls vendor about that. So now I'm going to pass it over to Taylor from Xcel, and he's going to talk about the retro commissioning program. And I think the next slide is just the thank you slide. So thanks for joining me.
All right. Thanks, Eric, for that. That was really good. I think Eric provided a lot of applicable real-world type of situations that I see come through all the time via efficiency projects. Like he mentioned and like Carl had mentioned briefly, I am a program manager at Xcel Energy. Program I'm talking today is Xcel Energy's Recommissioning Program, which is a study offering in our efficiency portfolio, which is designed really to help customers and incentivize customers for implementing a lot of the solutions that Eric was talking about today. So I'll walk through the basic components. First off, just talk a little bit about the definition of recommissioning, at least as Xcel Energy sees it. It really is reviewing a building's existing mechanical and lighting systems, and along with the building controls, that as Eric had mentioned, to ensure they're working as efficiently as possible and that, you know, the operations are tight or as they were intended when they were originally put in place. When you're looking at tuning up existing equipment, not adding anything new, typically what you'll find is that the optimization of those systems will expose some low to no cost measures with attractive paybacks for customers, which is really what I want to try and focus on today, just the overall benefit of that. So recommissioning reviews, actually Carl, can you go back a slide? My apologies on that. I should have mentioned the typical, you know, phases or timelines of our recommissioning projects are really split up into 3 different chunks, starting with, you know, the application process that our customers complete and the pre-approval process up front, really just gauging the potential within the building and making sure that they are a good fit for a study program like this, and that it is worthwhile, worth their time, worth their money to engage in this type of service. The second phase would be the investigation phase, which is the engineer or third-party vendor going through their building, walking through and identifying all the opportunities like Eric had mentioned. Once that is complete, typically those vendors will provide a study report back to the customer, which outlines all of the opportunities that they found. Typically each measure, each conservation opportunity has an associated amount of savings with it, as well as, you know, the cost of the opportunity and the paybacks if the customer were to implement. After that step takes place, it's really up to the customer to decide whether or not they want to go forward and implement any or all opportunities and at what point in time they would like to do that. One big benefit of the recommissioning program is that it doesn't really put those, you know, decisions on a fast track. So once they're identified for the customers, you have up to 7 years to really plan out those improvements and implement as many as you would like. And it's kind of nice that it can be fit into your budgeting schedule. So now getting into the review itself, or phase 2, if you will, of the last slide, which is the vendor being on site and walking through and trying to identify some energy-saving measures for the customer. They'll take a look at all the existing systems within your buildings. You're talking central heating and cooling, air handling units, exhaust systems, etc. And then they'll look at all the existing controls that you have in place. I think Eric did a really good job of talking about any potential overrides that may have taken place over time that are now causing the existing controls to be out of alignment with, you know, your occupancy schedules or other things like that. So they'll take a look at any controls improvements that they could possibly make, such as resetting some of the equipment so that it's not running at unnecessary times, or looking to optimize start and stop times so that it's not costing you guys too much to ramp those systems up. One thing I would like to talk about is the difference between recommissioning and efficiency controls. Those are the naming conventions of our programs that we have internally, but they also speak to separate services. So efficiency control is also part of our efficiency program portfolio, which is really in place to capture all capital improvements pertaining to an energy management system or control system. So the big difference in these two is that when a vendor is walking through your building and identifying these opportunities, the intent is not to identify large capital improvements that you would need to make in order to have your building run more efficiently. It's really in taking a look at what you have in place and identifying the low-hanging fruit via tune-up opportunities. So any proposed new equipment or systems would not be captured through the recommissioning program. That's not to say that the vendor can't identify those, and you know, sometimes there is, we do just come to that conclusion, or the vendor does come to that conclusion if they feel like there's not, that system doesn't have the sophistication to really capture the largest benefit for the customer. But for the most part, we would like to keep the focal point of these studies off of those types of improvements. In the table, it kind of breaks out some examples of what types of improvements would fall into each bucket. So on the recommissioning side, you have adding a point to an existing system, adding lines of code to the software, or correcting or improving control settings. On the efficiency control side, you'd have, if you're going to replace your EMS system altogether from pneumatic to DDC, if you're going to add a control subsystem or system because you don't currently have one in place, or if you're upgrading your software to a higher version. Since we have a program in place to incentivize customers through that in efficiency controls, we just ask that you keep those types of improvements out of a recommissioning scope. Some benefits and common measures through the recommissioning process that we typically find are for our customers are reduced operations and maintenance costs, sometimes as high as 15% savings on energy bills if the scheduling is really out of whack or running in excess. Extended equipment life. Eric talked a lot about improved comfort for occupants, which is really what we find is typically one of the main requirements that building operators have. But you're going to get independent, objective, expert direction on energy saving options. A lot of the times if a vendor is casing the entire building and doing a whole building audit, in a sense, they'll take a look at very briefly at lighting or any other improvements that they think you could take advantage of as well. And those, that objective advice and that expertise is extremely valuable. But you're also going to be incentivized to make some of these improvements. I think, one of the trade-offs of the recommissioning program is that customers would have to hire a vendor to come in and pay them a decent sum of money to identify all these opportunities, and the longer that they're on site, the more it costs. So Xcel is trying to enter the equation to provide some rebates and offset some of those project costs. Some common measures that we find through recommissioning studies that are then implemented, I think we've done actually a pretty good job of covering all of these to this point, but tuning up EMS system points and scheduling changes are probably the biggest improvement that we see. So I touched briefly on this last slide, but our role in recommissioning services, we come in at the ground level before a customer has obviously started working with the vendor and look to provide them with additional resources necessary to complete these studies. A connection to an experienced trade network. We have a list of pre-approved providers that we allow, in a sense, to work with our customers in our service territories. We also allow study funding at the very beginning to lower some of the project costs, like I mentioned last slide. Once the study is complete and, say the customer is interested in moving forward with an implementation project, we would offer additional rebates at that time to make these energy-saving projects more affordable. I mean, a lot of times these are, like Eric had mentioned, the low-hanging fruit or the cost-effective options, but a little extra money can go a long way sometimes, even with getting through or getting approved attractive payback types of projects. And then in exchange for the support that we offer, we do get to claim the energy and demand savings from implementation projects. So that's really where the finish line that we're trying to get to from the utilities perspective is making sure that we're providing a service that extends the extra mile to make sure that these improvements are put in place. So now I'll talk a little bit about the specifics and some of the parameters that we have in place on the program itself. I mentioned a couple of times that we offer study funding. We provide up to 75% of the total study costs, capped at $25,000. I would say keyword would be up to here. While we're not against funding studies 75%, there have been some confusions in the past. People just see the flat number and expect to get that, and really the percentage that customers will receive in study funding is dependent on the recommissioning potential, or all those tune-up-like measures, how many of those we basically think are available within a space, and the benefit that we can get in terms of total energy savings back from that particular project. Implementation rebates, we do offer what we call a base rebate and bonus rebate. So base would be up to $400 per kW, or 4.5 cents per kilowatt hour that was implemented through projects. After the fact of the study, the customer in this case would get whichever rate is higher. Natural gas, for Xcel gas customers only, would get up to $5 per decatherm. For all base rebates, they must have a payback period between 9 months and 15 years, so anything under 9 months would not be incentivized through a base rebate, because basically it pays back too quickly and it's already cost effective enough at the outset. And anything over 15 years, we typically recommend that the customer looks for a different solution unless it's an absolute need, if we would not incentivize those. Base rebates are capped at 60% of the project cost. That's usually going to be in direct alignment with that 9-month payback period limitation as well. Specific to the recommissioning program, though, there are bonus rebates that we offer, because a lot of times the attractive payback measures that we have in our entire portfolio are coming through the recommissioning program. We have a lot of implementation projects done that pay back in under 9 months. We instituted an additional kicker so that customers that, our ideal customers that, have identified and implemented only low and no cost savings will get some amount of money back from us for doing so. So electric would be 3 cents per kilowatt hour, natural gas $3 per decatherm. These do expire 9 months after the study approval date, which is typically when the vendor will share the results of the study with the customer. So we like to, it does force the issue a little bit, but we like to get people moving on the measures that we think are make the most sense. And the bonus rebates are capped at $10,000 or the remaining out-of-pocket costs of the study. So another thing we've seen is a customer gets 75% study funding. Say the study cost is $20,000, they get $15,000, then their bonus rebates for any implementation projects would be capped at $5,000 then, because that was the remaining delta at the time of the study funding. This is the exact same details, but I believe we will be sending the slides out after today, so this is just a good reference slide for everybody. I think it tells it in a little clearer of a picture than the last slide. So I will get into one case study of a customer that I thought was had a space that was applicable for this audience, which was Southtown Office Park. This is in Bloomington. They participated in our recommissioning program. time of application, they were rewarded with 75% study funding. So I believe the study cost was $15,000, and they ended up getting back just over $11,000. A number of things were identified and then also implemented, and they received $33,600 in implementation rebates. On top of that, they were finding savings of $118,000 a year. Now, this is obviously subject to change as schedules change. Some of the results that we claimed may also be different. They might not be seeing that exact amount year over year, but when the plan was put in place, that was what was projected. One of the big success stories of Southtown, though, I think, was that they split their implementations up into phases, and really they worked perfectly within the structure and the parameters of the program. So a couple of the implementation projects didn't make sense for them right when the study was approved, but they were able to go in, do the low-hanging fruit options, get their maximum bonus rebate from Xcel Energy, and then map out some of the other improvements for a time that worked better with their budgeting cycle. And lastly, I would just like to touch on our building operator certification offering that we have as well. This is separate from the recommissioning program, but results commonly in the identification of a number of different recommissioning-like measures, if you will. What BOC is a nationally recognized training program, and it's really focused on building operations and preventative maintenance measures. It gives customers a number of benefits, including finding new and unique ways to save energy and money within your space, improving the comfort and air quality through low and no-cost solutions, and knowledge. Giving you guys, or giving the customers the knowledge to perform these operational improvements on site. I know, like Eric mentioned, we're not all experts, myself included. I get, even being the program manager of these offerings, I get extremely confused sometimes at some of the operational improvements that customers are making. So a little knowledge to give you some confidence digging into these types of projects. So topics covered would be measuring energy performance, energy efficient lighting and HVAC controls fundamentals, and then they do focus a great deal of time on the low and no cost operational improvements. The main difference, I would say, between recommissioning and building operator certification is that you basically would end up doing the identification process by yourself through the knowledge that was gained in the course, rather than having an expert on site doing those things for you. BOC course is 8 days of class that total 74 hours, so it's just lecture-based by industry professionals, both current and then retired as well. It carries a $1,700 cost. 30% of that, $500, would be offset by Xcel Energy, and then we would follow up with all customers once they've completed the course to see if there are any rebate offerings in our portfolio that will be suitable for them. Doesn't look like I thought I included the hyperlink, but I can send out some information on how you would enroll in that program itself after the presentation today. Oh, actually, I have it on the next slide. I knew I had it somewhere. So if you follow that link, you can get more information on the building operator certification offering. There are no trainings that will be taking place the rest of 2018, but we will be launching some Xcel Energy supported courses come 2019, so look for those. And then also give you guys a direct link to the recommissioning program page on our website if you'd like more details on that offering itself, and also available via phone or email here if you have any questions on the content we covered today.
Great, thank you. All right, well, we'll turn it to Q&A for a few minutes here at the end. So one question, Taylor, for you. that came in here is, are there any plans to bring the VOC training closer to the Twin Cities?
Yeah, we actually had one course this spring in March, which was just right off of 394 near Ridgedale. Like I kind of mentioned, we don't have anything slated for 2018. I know a lot of the professors that Mia, who is the program administrator, a lot of the instructors that they hire are booked through the end of the year. But we do have plans to bring another Twin Cities course, or to hold a Twin Cities course. I think next spring will be when we have our next one.
Great, thanks. Okay, so one question here. As a building manager, if I pay for the best engineering firm and best architect to design my new building, why should I pay to have it commissioned and recommissioned? Shouldn't that all be taken care of from the design of the building?
I'll speak first, and I'll kick it over to the technical expert, Eric. I think one thing we did talk about a lot today was that things change and overrides are put in place over time. So if you think about a typical day as a building operator, you might get a call from anywhere in the building saying it's too hot here, it's too cold in a certain space, and oftentimes you're asked to make changes to your control system to take care of that. And anytime one of those changes is put in place, there's direct repercussions, but it also might affect different components of the overall system, as Eric had mentioned. So sequences can get out of whack pretty quickly from what I've seen.
Yeah, I'd like to reframe the question just slightly too, because I'll often hear, if I've got a new building, why should I be looking at something like this? If the building's maybe only 5 years old, could it be that screwed up? So, there's a number of reasons why you might think that a building should have no problems if it's got great design teams and it's a relatively new building. But one of the things that I like to point out is that a new building is a very complex and custom system, that isn't necessarily reflective of what we typically think of as new. When we think of new, we think things that have come off of a manufacturing line, which have really high specifications as far as how new pieces of equipment should perform. So we typically hear new, and we think that it's going to work for at least a couple years perfectly, and realistically, that's not how buildings tend to operate. You may have one of the rare cases where things are done really well, but oftentimes in very custom, large types of projects like building construction, little things can add up, and they're even if it's designed really well, certain things either right off the bat are set up incorrectly, or could be pretty quickly put out of line. So like one of my examples that showed we found some substantial savings. I think it was almost 30% energy savings on a building that we did in about 3 years after it was built. So, and that it was no fault of the engineers and the architects. It's just there's always different things that happen that could not have been forecast or were changed at some point early in the building's operation. So there's usually opportunities out there, even in young buildings or well-designed buildings.
One more thing I would add is that typically in the design phase of a project, they're basing the occupancy off of expectations or projections, and those things can change very quickly. Floor plans can change a number of times over a 3 to 5 year period, and every group of people, of occupants, uses the space a little bit differently, so that can affect things as well.
It's a really good point.
Great, thanks, guys. Another question here. So is there a subset of control changes or scheduling that a building user or a building manager can do for themselves? When does it make sense to talk to a contractor or to enroll in Xcel's RCX program?
Yeah, I would say that, you know, the guidance that you're given from your controls contractor at the time of installment and the general commissioning practice, at that point, anything they give to you that day and that you feel comfortable with, I would say is okay. But certainly if you're noticing your utility bills hiking and aren't really sure of, you know, what the problem is because all the equipment is functioning and working, then I'd say it would be at that time that I would reach out to my account manager at Xcel and really ask them what they think the best step forward would be. Oftentimes, if it's your operations that you have in question, they're going to point you to the recommissioning program.
Yeah, in terms of specific operational changes that you could be making, you know, it really depends on the building operator's expertise, the amount of controllability and flexibility that they currently have in that building, and probably most importantly, the amount of time that they have. So if a contractor, if a building owner and facilities team has the best people and all the capabilities to be able to do whatever types of changes that they want, but they don't have the time for it, you know, having projects that pay back in 1 month but never get done isn't it worth very much. So maybe having it be a 5-month or 1-year payback, but having it actually being done with some help, some outside help, can actually make those projects come to fruition. So it kind of varies from case to case, and you can always chat it over with an engineering firm or some outside help. You know, Xcel Energy, I know, has got all sorts of resources to help guide some of those decisions, and they can always help as a first step or first resource to reach out to. So I would just say, you know, getting something done is better than not getting something done. So wherever that line is drawn within the organization is important to determine, and use that to determine when to reach out to somebody else.
Yeah, I would add also, you know, if you feel like you have a lot of manual processes that you make on a daily or weekly basis, that might be a good sign that there may be something more that your control system or energy management systems can do for you if you feel like they are sophisticated enough to handle more of that workload, I guess, if you will. So like Eric had mentioned, getting on the phone with a third-party vendor, a lot of times they'll be willing to find out some more about your equipment, about your systems, and walk you through some of the things that you could do without even really having you on the hook for any costs at that point, or doing any of the walkthrough work like I mentioned. And so, you know, Michael's Energy being one of our approved providers here in the Twin Cities territory, I would, you know, encourage you guys to look at the recommissioning webpage on Xcel's website and look through the list of providers that we have here in the area, just so that you have one, you know, on deck for when things might go awry.
Great. I don't see any more questions coming in, and we're getting close to time, but are there any other comments that either of you want to share with the audience?
I'd just like to thank everybody for joining us, and feel free to reach out to either one of us to ask any more specific questions if you have any.
Yeah, I think if at any point today something seemed like it might be applicable to the current state of your building, I know everybody involved in the presentation would be more than willing to reach out and help. So hope to be in touch with some of you.
Great. Well, thank you, and thank you all for attending. We'll send out the slides, and the webinar is recorded and will be available online too. Have a great day.